Nice to meet you. Could you explain to us what you are doing here at the Criobe?
My name is Bouyoucos, and I'm a PhD candidate based at James Cook University in Townsville, Australia, and also at the École Pratique des Hautes Études based in France. So I'm here studying how the reef sharks that we find around the island, how they're able to kind of go about their daily lives and deal with the various sources of stress that they might experience in their environment, how these animals are still going to be able to do that as the conditions change with climate change. Now, French Polynesia is a fantastic place to come and study sharks. It's the largest shark sanctuary in the world, meaning that these animals are protected from targeted fishing. That's the biggest threat to many shark populations worldwide. But what we do know is that these marine parks can't necessarily protect these animals from climate change. Now, climate change is going to be a threat, and we have to understand how it's going to affect these animals so we can better manage and conserve these animals into the future. So my research with newborn sharks that we find around Moorea, blacktip reef sharks and sicklefin lemon sharks, two of the most common species, my research involves trying to understand how these animals are able to cope with stress that they experience now under the current environmental conditions that they face, and then to bring these animals into a laboratory setting and simulate conditions that we know they'll experience, but that we predict they'll experience at the end of the century if climate change progresses the way that it does, and try and understand, are these animals any better at tolerating those stresses? Are they any worse at tolerating them? Or are they simply able to cope? So one of the major techniques that I use involves monitoring the environmental conditions that these animals experience in their environment. So these animals are born during the hottest months of the year, during the summer, and they live in very shallow water, from anything less than a meter to 10 or 20 centimeters sometimes. This water during the day can get very hot, also because there's so much primary productivity going on. So many animals consuming oxygen, so much algae producing oxygen but consuming it at night. We know these habitats also get a bit hypoxic at night, meaning it's not a lot of oxygen in the water. So these animals have to contend with very, very variable environmental conditions, with temperature, with oxygen, potentially with the salinity in their environment if you get big rainfall events, and maybe even the acidity of these environments with changes in primary productivity. So one of the important parts of my research is to be able to monitor these conditions where we find the sharks, so that the experiments I run in the laboratory can be based off of ecologically relevant conditions. Now, to look at how these animals respond to stress, I use two main techniques. The first involves taking blood samples and then analyzing various aspects of the blood using handheld portable devices. Now, some of these devices are used by veterinarians. Some of these devices can be bought off the shelf in a pharmacy, and these give us a quick snapshot. They're quick diagnostic tools to be able to tell us how stressed an animal is, whether it is necessarily stressed, and to give us an idea of how the animal responds to a stress. Now, some of these stresses I'm talking about in particular are fishing, capture. This is a big one. Now, we know these animals are protected, so there's no targeted fishing going on, but that doesn't preclude these animals from getting caught accidentally in people's fishing gear. Getting caught, it's exercise. It's inherently stressful for these animals, and we need to know under what conditions, if they get caught accidentally, they'll be able to survive and move on. Environmental stress, like rapid increases or decreases in temperature, can be stressful. Decreases in the oxygen availability can be stressful, as well as changes in salinity, changes in pH, all potentially stressful conditions. The second technique I was referring to, how we look at how these animals respond to stress, is called respirometry. Now, respirometry is widely used for animals. It's used in humans as well. Human athletes, we will measure the amount of oxygen that we extract at different levels of activity under different conditions. And so respirometry with fish works very much the same. It involves having a chamber of a known volume with a known amount of oxygen in it, and oxygen probes in the chamber to measure what's going on. By putting a fish in it, the fish is going to consume oxygen in the chamber, and we can measure the rate at which there's a decline in oxygen. That gives us an idea of the animal's what's called its oxygen uptake rate, And this gives us a little bit of an idea of potentially what the animal's metabolic rate is doing. Now, by having these animals undergo respirometry at different temperature conditions, at different pH conditions, we can get an idea of how their metabolism is changing based on changes in environmental conditions they experience today, as well as environmental conditions that they'd experience at the end of the century. And so that is a major tool to be able to tell us what's going on at a physiological level that's affecting how these animals can cope with changes in their environment. My PhD research is a part of a larger series of projects referred to as Physioshark. Now, Physioshark was started in 2014 by my supervisor, Associate Professor Jody Rummer, who's based at the Australian Research Council Centre of Excellence for Coral Reef Studies in Townsville, Australia. Now, one of the main goals of Physioshark is to try and understand how sharks will respond to changes in their environment that are associated with climate change. Now, climate change is one of the documented threats. It's one of the acknowledged threats to sharks, but we really don't know that much about how these animals will respond. So the overall goal is to try and understand to what extent climate change is a threat to these animals, and that can ultimately better aid in managing these in many cases threatened or protected species. Now, if we know that climate change is going to be a problem, we can potentially try and mitigate other threats, other sources of stress that we know these sharks might face alongside climate change.
Thank you very much, Jan. Thank you.